Hello and welcome to Sunday's edition of Cracking the Cryptic, and on screen today we've got a puzzle by Sed Holaysan. Sed's from the Philippines and he's appeared on the channel a few times before. His puzzles are always extremely popular, and I think one of the reasons is that Sed's speciality is puzzles that are sort of medium difficulty but extremely elegant. So if you find some of the stuff that we cover on Cracking the Cryptic really difficult, today is definitely a day to try the puzzle, because I'm sure you'll be able to get through this, and I'm also sure you'll enjoy the process of solving it. Now, one of the reasons we're going to cover this puzzle indeed is because of a conversation I was having on our Discord server the other day, when somebody asked me, and it struck me as a question I shouldn't get asked, but then it made me think, why am I being asked this question? And they asked whether we had an aversion to doing easy puzzles on the channel. Well, that's definitely not true, although I do accept, as I think back, that we do tend to cover stuff at the harder end of the spectrum. And the criteria we basically use for picking puzzles is not whether they're easy or hard, it's whether they are interesting, whether they have something about them that makes us sort of, wonder at the logic. And with very easy puzzles, if you were to take a classic Sudoku from a newspaper, for example, that I'm sure would be fairly dull for everybody, because although we could all do it, we probably wouldn't remember the process of doing it. We'd forget the puzzle almost instantly, and it would just be some way that we'd spent time rather than something we got an immense amount of satisfaction from. So when we do choose easier puzzles, we do want to make sure that they are good. Now, Mark's tested this one and he says it is beautiful. So yeah, I think you're in for a treat. Anything else to mention? We are going to release a crossword video actually on the main channel, either later today or tomorrow, in which both Mark and I tackle a cryptic crossword, different cryptic crosswords I should add, but the reason hopefully will become clear. But yeah, if you're into your cryptic crosswords, there's going to be quite a lot of stuff in that video that you might enjoy. Now, what are the rules of Sed's puzzles? Let me read them. What we've got it's called different Sudoku. Normal Sudoku rules apply. Clues between cells indicate the difference of the digits in the two cells. So if we look at this 5 domino here, it's got a 5 in between the two cells. So whatever I put in this square has got to be 5 different from whatever I put in that square. So if this was a 1, this would have to be a 6. If this was a 9, this would have to be a 4. So it's quite a simple rule, and it's a puzzle type actually that's quite popular in competitive Sudoku. So it's often a puzzle type you'll see at the World Sudoku Championships, and I suspect, based off Mark's comments, that this is approximately as difficult as you'd find a puzzle in the World Puzzle Championship or World Sudoku Championship. World Sudoku Championship puzzles tend to be elegant but not brutally hard. It is, after all, a speed-solving competition. So the way to play, as usual, is to click the link under the video, and now it's my turn. You can see I'm on the new software today. So let's see how that goes. Let's get cracking. Now, do I have any tips for different Sudoku? Well, normally the best place to start is with the highest digits, because they are incredibly restrained, and 8 is the most restrained, because obviously 2 digits that are 8 apart, they have to be 1 and 9. Now, in fact, look, this 1, 9 has an effect on these 7 dominoes, because what are the options for 7 dominoes in this kind of puzzle? Well, if you put a 1 in a cell, you have to put an 8 with it. If you put a 2 in a cell, you have to put a 9 with it. And basically 1, 8 and 2, 9 are the only options for cells that differ by 7. But this box already has a 1, 9 in it, so we can remove 1, 9 from both of those squares. And that means we can move 2, 8 from both of those squares. Right, okay, so now I can see this. I can see the theme emerging here, because what we've got is we had to solve the 8, and that led us on to the 7, and now it looks to me like that's going to lead us on to the 6, which is going to lead us on to the 5. Let's see. So these two cells in the 6 are both in 6 relationships. So what are the options for these two cells? Well, I think it's only 3 and 7, because if we can't put 1, 2, 8 and 9 into these two squares, the only other digits that would have a valid option 6 away from them are 3, which would go to 9, and 7, which would go to 1. So these are 1 and 9. In fact, there's a 9 here. Right, so this is 1, this is 7, this is 3, and this is 9. And now let's carry on. Let's use the 5s then, because if... yeah, we're going to get a quadruple here as well, because these squares could be 2 and 7. That would be a valid arrangement 5 apart, or 3 and 8. But they can't be 1 and 6, and they can't be 9 and 4. So again, look, we get a quadruple along here, although this one... well, it looks like we can eliminate some of the options using the columns. Look, this square can't be 2, so this square can't be 7. And this square can't be 3, so that square can't be 8. This square can't be 7, so this square can't be 2. That can't be 3, so that can't be 8. Don't think we can use the 3 yet. Maybe we can. What are the options for this square? 4, 5 or 6? No, that doesn't look... oh, no, I don't think it is this domino, but I do think this 4, 5 and 6 is interesting, because we've got... yeah, look at row 3. What digits are missing? What digits do we have to put into those 3 squares? Well, we've got to put 4, 5 and 6 in. So we get a 4, 5, 6 triple down this column, look. In fact, we've got the same thing there, look. This row as well. We haven't placed 4, 5 and 6. So we've now got 4, 5, 6 swordfish in the grid. But you know, it's simpler than a swordfish, or it's the simplest type of swordfish in the sense that these are all triples. So, what does this mean? It means that... sorry, I'm just trying to spot whether there's an obvious thing it means. There is... yeah, there you go. This square is restricted. This square is restricted. Why is it restricted? Well, if we can't put a 4, 5 or a 6 in this square, and it's 1 away from a digit that is 4, 5 or 6, it must be either a 3 or a 7. It must be 1 away from an extreme digit in this square. And it can't be 3 because there's a 3 there. So I think this has to be a 7, which means this is a 6. Get rid of 6's from there, get rid of 6's from here. And maybe we look at... yeah, we do. We look at this square now. We look at this square because this is 2 away from a 4 or a 5. But 3 and 7 are not available in this square. And obviously we can't put 4, 5 or 6 into this square either. So this must be 1 away from the extreme again. This must be a 2 or an 8. Oh, and it can't be an 8 because there's an 8 in the box. So this is a 2. This must be a 4. This, no 4's up here. This must be a 5. Get rid of 5's from those squares. So that square is a bit restricted now. This can be a 1. Oh, it can't be a 1. There's a 1 and 9 pair. No, it can't be a 1. It can be a 7. 4 plus 3 equals 7. Or it can be a 3. Or it can't be a 9. So this has to be 3 or 7. Ah, but it's a knight's move away. No, just joking. There's no knight's move restriction here. I'm trying desperately to see whether I can work out what that is, but for some reason I'm not spotting how to do that. Okay, where do we look now? Well, we could look at... I think we could look at these squares or this domino. That's where my eyes are drawing me anyway. Let's look up here. This square has to be 4 away from whatever we put in this square. So if this is a 4, this has to be an 8. If this is a 5, this has to be a 1 or a 9. And I can't see why any of that is impossible. If this is a 5, we get 1, 9 in there. If this is a 6, there you go. So it's this one that's the important one, because this can't be a 6, because if this is a 6, the only option here would be a 2. We can't put 10 into this square. I don't even think I can put 10 into this square. No, the new software allows me to enter 0, 1, but not 10. Anyway, I don't want to enter either of those. This has to be a 1 or a 9 now, which means this has to be a 5. This has to be a 6. This 5 means that's a 4, that's a 5, that's a 6, that's a 4. That's important, because that... Oh no, yeah, it is important. This can't be 3 now, so that's 7. Where does 3 go in column 5? This 3 tells us it must be here. These two squares are 2 and 8. We can fill them in. These two squares are 4 and 6. We can not fill them in, but we can pencil mark them. If this must be an 8 now, because it's 4 away from this digit. This 3 tells us the parity of this one, or tells us exactly what it is. Now that might be important, because that gives us the 7 here, gives us the 3, gives us the 8. This 8 gives us the 2, which means this must be a 9. This is a 1, and this is an 8, and we are cooking most certainly with gas in this puzzle. 9, 1. But hopefully you can see what I mean. Although this is definitely easier than some of the brutes I've been faced with recently, it's still extremely enjoyable, and it's interesting logically. And that's exactly what you want from an easier puzzle. Now, let me just stare at this for a second. This domino I want to look at now. Now, why this domino? Well, a 2 clue in a different Sudoku means that the domino retains its parity. So if this square is even, this square has to be even. Now look, in this box we've already got 2, 4 and 8 in the box. So we can't put an even number in here. It's impossible. So it must be an odd number. And in fact we know for sure this is 5 and 7. Now how do we know that? Once we know it's an odd number, because there's a 3 in the box, we can't put 1 in this domino. We can't put 3 in it. We can't put 9 in it. So the only options are 5 and 7. 7 over here tells us the order. 7, 5. These squares have got to be, well, they've got to have a 6 in them. I can see that, and there's a 6 there. So before I scan the rest of it, let's just get the 6 in. That's a 9. This is a 1. 3, 5 and 8, I think, over here. 5, 8 in that column. So this is 3. This is a 5, 8 pair. These squares have got to be 1 and 4. If that's right, obviously the 1 here is quite helpful. 4, 5, 8, 1. 1 by Sudoku up there. These two squares have got to be 2 and 9, which we don't know the order of. We've almost used all of the difference clues now. Oh, there's these ones. I almost missed that. Look, there's a little 1 hidden in the middle of there. A 1 here and a 2 here. So we've got 4 clues left to use, I think. Let's just finish off these columns. We've got 2, 3 at the top here because of this 2, this 3. Those two squares, therefore, have got to be 5 and 6. Looking down this column, you can see we need 6 and 8 into those squares. And 4 and 7 into those squares, and there's a 7 here. So that's a 7, that's a 4. This could still be 6 or 8. Bobbins. Okay. And maybe this column, we've got loads in this column. 2, sorry, not 2, we need 3, 7 and 8. 7 must go at the top because of these 7s and this 7. So 7 goes up here. These two are 3 and 8. We can do that, look. That fixes our 8 and our 6. Three, 7 and 9 have gone. So again, we can check this very quickly for parity. This can't be an odd digit because 1 and 5 is impossible. So we know it's even. It can't be 6 and 8. It must be 2 and 4. That does fix our 2 and our 9. That fixes a 9 by Sudoku in the central box. We need 1, 5 and 6. So this is 6, this is 1, this is 5, this is 6, this is 4. That's a 5 by Sudoku. This is a 1 by Sudoku. 2, 3, 7, 4. It's going to be nice this because I'm not going to need to sort of put my head in a cold towel after this one, as sometimes has been the case recently. 3, 5 into those squares. Presumably, yeah, this 7 is 1 away from that digit, so that's got to be a 6, that's a 5, that's a 5, that's a 3, that's a 3, that's a 2. This has got to be 4 or 6, it can't be 6, that's a 4. That fixes the 4, 2 at the bottom. I really hope I've not made an error here. I need 2, 4, and no, 2, 6, and 8. So 8 goes here, 2 goes here, 6 goes here. Check. Yes, that's how to solve different Sudoku. So yeah, a little bit easier today, but no less enjoyable. Do let me know in the comments whether you enjoyed it. Let me know if you'd like to see something slightly easier a bit more often on the channel, or a bit less often. All opinions welcome, of course. And Mark will be back later with another edition of Cracking the Cryptic.